Always bear in mind that a really simple way to create syntax is simply by exploiting the paste button that you get in most SPSS dialogues. So if there are certain procedures that you run all the time, like frequencies or crosstabs or correlations, you can configure the dialog in your normal way, specifying the fields that you want to include and any options that you have, sorting or formatting, whatever. And then instead of clicking OK, if you click paste, it will show you the syntax that SPSS is executing. But in the next few examples, we're going to delve into different aspects of syntax that illustrate how these procedures work and reveal perhaps hidden functions that aren't obvious to the casual user, and even look at a couple of procedures that don't have their own dialog box, so you wouldn't necessarily encounter them. And to begin with, we're just going to start this off by looking at opening data in IBM SPSS statistics. And if we look at the first classic command, which is the get file command, the get file command is used to import a native SPSS data file. So this is what's being executed when you're importing an SAV file, a data file written by SPSS to be used in SPSS. And you can see here it's a very simple file structure, command structure. Get file equals, and then the address ctemp, which is the folder that we're working in, and then the name of the file, employee.sav in this example, with a full stop at the end, with the address in quotes. So really simple little procedure there. The get data command, however, is different, and this is used to import non-native file formats such as Excel workbooks or tab separated or comma separated files. And here we have an additional subcommand, which is the /type subcommand, and that specifies the type of file to be imported, whether it be an XLS or an XLSX file. And then we have a /file that basically says, okay, here comes the address of the file and the name of the file with a full stop at the end. So just to illustrate that, if I just jump out to syntax here, if I'm going to put on the caps lock just to make it clearer. If I type in get, you can see here that there is a lot of different procedures beginning with get. There's get capture, get SAS, get stata, get translate, get cognos. We want get data, which is our generic procedure for importing non-native SPSS files. And I'm just going to, I don't have to, but I'm going to put a carriage return in here and then put /. And if I put / in there, you can see it says, well, what do you want? And if I say, well, I want to specify the type of file, so /type is equal to. And if I put equal to, you can see what's this, 6 different types that we can read in. ODBC, OLADB, these are for reading database files, so connecting to a database. TXT, that would include CSV files and tab separated files, and then 3 different types of Excel file, XLS, XLSM, and XLSX. So if I just went for an XLS file, there we go. And again, for clarity reasons, I'm just going to put a full stop. Now we need to put in the address of the file. So we put another / in here and say file, and then equals, and then it would be the address of the file if you like. So it'd just be XYZ, .sav, I guess. And we could put it in ctemp, assuming it's in ctemp, C:/temp. And that's it. If that file exists, that would read it. And of course, we got to put a full stop at the end. And we put a full stop at the end. The get data is incorrectly formatted as blue. So not a difficult procedure to get your head around. A really useful trick, however, is the use of the cd command. And this is really useful when you're reading files on a regular basis from perhaps quite a long address, or you're using a lot of nested subfolders, and typing them in tends to lead to spelling mistakes, or you've got to do it a few times. So instead of, for example, using get file to read this January SAV file and specifying the really long address here of nested folders from C users, CW Jones, documents, monthly reports, what we can do is use the cd command just by typing cd and then writing out the address, C users, CW Jones, monthly reports. Just type out the address and then simply type get file january.sav, and it will assume that this is the default directory and it will read it directly from that folder. So just to illustrate that, let's look at, here we can see a really simple, this isn't a very long address, but we've got a little file here called employee data with age .sav. And if I use get file here, you can see it's going to read it from C temp. I'm running that. Just gonna read that file in. Where is it here? Here it is. Okay, so it reads that file in. Let's just close it down, get rid of it. And if I go back to syntax here, I'm going to use my cd command. So I go cd, and then all I got to do is just put the quotes in. So I say cd. I don't need the equal sign. And just ctemp, really. Not a very long address, but you get the idea. Full stop at the end of it. Put this in quotes. Yeah. Then run that. You can see that says, okay, ctemp is now in the log file. It's showing me in the hidden log file here that that's been specified. So if I go back to the syntax here and I just copy this. All right. And just get rid of the address. So it simply says employee data with age. Get file employee data with age with no address. Run that. It says it's got it, and we go and we find that it's actually read that file in. So CD, quite a useful little procedure to be aware of. If you've ever read non-SPSS data, such as an Excel file or CSV file in the SPSS, you'll know that you normally need to apply some sort of labeling to the imported data, to the new variables. That's because file types like CSV and Excel, they don't store variable labels and value labels in the same way that SPSS SAV files do. So you may do that through something like the variable view window, where you normally go in and manually attach these labels to it. And you may notice that the variable view window actually doesn't have its own paste button. So knowing the syntax of how to attach labels, for example, to specific variables and to specific values is kind of useful. So for example, here the variable label command is shown for attaching a variable label to a field or a variable called jobcat, simply job category. And it's a very simple, again, very simple syntax here. Variable labels, jobcat, and then the label itself in quotes with a full stop at the end. So if I were to just illustrate that, I'll go back out to my employee data set here. So you can see here that the variable jobcat here, it's got no label in there. I'm just going to go to this little pre-prepared syntax file here where I've got variable labels jobcat, job category. If I just run that, running just that selection and come back to it, you can see that now the label has been correctly applied to that. So a really simple little procedure there. What about value labels? Well, value labels work in a similar way, but bear in mind that using standard value labels command will mean that you overwrite any existing value labels. So here I've got the value labels for the 3 different values of the variable jobcat. And again, very simple procedure here. Value labels jobcat 1 with the quotes clerical 2, single quotes custodial 3, single quotes manager with a full stop in the end. So again, if I go back to labels and recodes here, you can see that we have no value labels in there. Okay, no value labels in there. So if I just go back and I'll tick off the comment for this to make this active. So instantly I can now run that, and it attaches, as you can see, the value labels to it really simply. But what happens if we just wanted to not re-specify all of the labels, rather just add an additional label? Maybe we're anticipating that a new value could occur, perhaps in data that's forthcoming, or data that we expect to get next week or something like that, or some new category that we've created. We have this additional little command called add value labels, which is useful when you want to create a new category, even if that category doesn't exist. So I've got a 4th category here called VP for Vice President. And again, I can execute that by going add value labels jobcat. The value is 4 and the label is VP in quotes. I run that and then come back to the data set, and now we've got this 4th value label. Even though we don't have any data that is VP or category 4, it's attached that value label to it. Our next syntax example actually focuses on the recode procedure, and the recode procedure is a very commonly used procedure within SPSS, where we use it to reassign values, to change the underlying values of a variable. So it might be that you want to take region and collapse regions together to create a variable that has fewer or more generic regions in it. Or you might want to use Recode to take a field like age and create a new field like age group or age band. So it's very much about changing the underlying values. And the reason we're focusing on it here is because many users actually find that recoding categories using syntax is easier and more intuitive than using the dialogues for it within SPSS. In fact, within SPSS there are two dialogues. One is for recoding or recoding over the same variable, so basically overwriting that variable, recode into the same variables. And one is for recoding into a different variable, so creating a new version of that variable. Here we can use Recode to create a new variable called jobcat2, and you can see I've just labeled it up here. It's a very simple command, recode, a single command word, then the name of the field that you are recoding. We've got a field called jobcat already. And then in parentheses, we've got a range value here, a range statement with an outcome. So we're saying 1 through 2 will now be coded as 1. So any value that is, for example, clerical, which is 1, or 2, custodial, will now just be given the code 1. And any value which is management, which is code 3, or potentially code 4, which is vice president, 3 through high, as an example, that will now be coded as code 2. And that will be used to create a new variable called jobcat2. So it's a very simple example here. Recode jobcat 1 through 2 equals 1, 3 through high, so 3 and higher equals 2, into jobcat2. And that means that you're going to end up with a new field called jobcat2 that consists of two values, simply 1 and 2. And generally speaking, when that happens, we want to assign some variable labels to it. So the full statement is going to look like this. There it is, recode, that's our recode statement. Then we're going to attach a variable label to jobcat2. We're going to call it management status. And we're going to attach code 1 has the value label non-manager, code 2 manager. And just to show that, if I just skip out to SPSS syntax here, I've already got it, of course, so I'll just remove the comment asterisks. And if I highlight that section and run it, and go back to the data, we find now that we've got an extra field here called jobcat2, which if I run descriptive statistics on, you can see consists of two values, non-manager and manager, with the variable label management status. If you're wondering about the use of decimal places here, it says 100 rather than simply 1. That's simply because all new fields, all new variables that are created by default in SPSS are given a width of 8 and 2 decimal places. There is syntax to change that to a width of 1 and 0 decimal places. It's the format syntax, but we're not going to touch on that at the moment. At the moment, we can simply remove this manually and just change this down to 1 for cosmetic purposes. In the last example of this section, we're going to look at the various methods we have for filtering data, for selecting cases, if you like, for analysis. And normally when people are using the dialog boxes, they'll use something like select cases to filter data. Select cases appears under the data menu in SPSS statistics. And here we have an example of a very simple select cases. We're using a conditional select. We're saying if condition is satisfied, if the variable age is greater than 30, then select it. Now what people notice is that when they hit the paste button down here, the syntax that is pasted is actually quite complicated, or it looks complicated at least. Given that it's such a simple statement, you think, well, why do you need all this sort of syntax? What's going on here? And if we start to take it apart, we can make sense of why it appears to be so verbose. One of the reasons that it's so complex is that reality what it's doing is it's creating this special field. It's creating this field, and it's using a compute command to create this field. So compute creates a new field for us using a formula. And this field is called filter underscore dollar. It's always called that. It overwrites it each time. Dollar indicates it's a system field. It's just a filter system field. And it's basically creating it saying, if age is greater than 30, then the outcome of this is that if it's greater than 30, you get a value of 1, and if you're not greater than 30, you get a value of 0. That's all it is. So after it's created this field, it then actually attaches a variable label to it, and it calls it age greater than 30, and then brackets filter. And it also attaches some value labels to it, where it says 0 means you're not selected, and 1 means you're selected, because this compute statement, as I say, only creates 2 values, 1 and 0. And then it actually uses this format. You heard me talking about formats in the last section. It formats it so it's got no decimal places and a width of 1. And then it actually executes the filter itself. It uses this command filter by filter underscore dollar. And this filter by is the bit where it actually says, okay, I'm only going to select people equal to the value 1. So this filter command starts to become relevant. Filtering data with syntax is usually generally less complicated, or produces less complicated syntax than you would get if you were hitting the paste button in the select cases dialog box. But the filter command is a good example of that, because the filter command allows us to filter out any cases that are equal to 0 or have missing values. So for example, here we have a variable called minority, and it's got 2 values. One is a 0, meaning no, they are not an ethnic minority. And the other value is 1, meaning yes, they are an ethnic minority. So if you use the following syntax, filter by minority, it would simply select everybody in the yes group, since filter filters out anybody is equal to 0 or has a missing value. So as an example of that, we just skip out to some example syntax here. We've got filter by minority. If I click run at that point, run selection, and go to the data set here, we can see that actually it's created these little scored out values here to indicate that this filter is switched on, and that the only cases that don't have these diagonal lines through them are in fact people who are in the yes group for minority. So if we just prove that by running descriptive statistics, you can see there's 105 people here in who are in the yes group for minority. That's all it's doing. If you want to switch off the filter, then very simply you just run this command filter off, go back to the data, and you can see that these diagonal scores have disappeared. We too can use procedures like compute or even recode to recreate what the select cases dialog does. And to do that, what we're going to do is we're going to create a new variable or new field that marks any of the cases that we don't want to include in our analysis with a 0 or a missing value, and then use the filter command, the filter by command, to select everybody else, because that's what filter does. So if we compute a new field, let's say, that selects managers over the age of 40, it's going to look like this. So we've got some statement here. Managers over 40 are given a value of 1. Everybody else is given a value of 0. We use the compute procedure here, and it says compute a new field called older managers. And that new field is going to be equal to people whose job category is 3, meaning they're a manager, and their age is greater than 40. And if they fall into that statement, if they fall into that group, then they're given a value of 1. And if they don't fall into that group, they're given a value of 0. And as we know, filter and filter by will select every case that's equal to 1 or any other number that isn't a 0 or isn't a missing value. So it will effectively select the older managers for us. So just to illustrate that, if I skip out to SPSS syntax here, I've got a little example here. It is the same example we saw earlier on. The only difference here is I've added in a command here called execute, which commonly follows a compute procedure. It just flushes the data so that the data physically appears in the data editor. If I put in a frequencies procedure after that, it would do the same thing. It's just, you can think of it almost as a convention of compute. So if I run that, just that statement there, compute older managers, or those where job cat is equal to 3 and age is greater than 40, and I run that, and then come to the data set, you can see that we've got this new field here. This new field here has a 0 or a 1, because that's what it does. And if they're a 1, then they're a manager. So you can see here, who are aged over 40. And if they're a 0, then that means either they're not a manager or they're not aged over 40. So if we then run filter by older managers, it will select anybody not equal to 0. So it will select all of the older managers. So we go back to the select cases here, and we can say filter by older managers. And you can see that suddenly these scores have appeared through the diagonal case headers. And in fact, filter on has appeared as a message down here. And everybody in this job category now will be a manager. There's 12 cases who are all managers. And let's have a look at age here. So we hit age and do descriptive statistics. The minimum age was 41. So we know that it selected managers over the age of 40. And if we go back to switch that off, all we're going to do is say filter off and run that. And it switches that filter off again. But an alternative to the filter command is the select if command. The downside of the select if command is that it permanently selects cases for analysis based on a logical expression. It will dump the records from the file, which is not always what you want. In fact, if you use the select if command, if you said, for example, select if gender equals F for female, you may notice that the data file seems to be unaffected, that the females are still in the data file, but the little message transformations pending appears on the data editor window. This is what the execute statement was doing in the previous statement, is getting rid of that transformations pending by causing a further pass of the data, which then updates the data file. So what would happen is if we did a frequency table or descriptives or a crosstab or something, when transformations pending is switched on, it means that you're forcing it to pass the data file one more time, and you'd notice that suddenly all the female cases disappeared. So the select if command really only takes effect, if you like, when another procedure like frequencies is run after the command is executed. So if I ran select if age is greater than 30, you get transformations pending. Nothing would seem to happen until I ran another procedure, which would effectively flush the data, and anybody who wasn't aged over 30 would be dumped from the data set, and you don't want that. So there's a little trick we can use, and the little trick we can use is another command. The command we can use is temporary, and temporary is a really useful command for lots of different procedures because it means that anything you do afterwards is literally temporary. So this is a useful procedure if you want to filter out unwanted cases for the next immediate procedure. So if I type temporary select if age is greater than 30, and then I ask for two frequency tables of exactly the same field, frequency table of job cat, it means that because the select statement is switched on and it's going to have a temporary effect, it means that nobody aged less than 30 or 30 or less than will be in that frequency table. But if I run it again afterwards, that temporary select is now switched off, and all cases will be included in it. So we'll see two different sets of results. So let's just illustrate that by going to back to our syntax. We'll go temporary, and we're saying this is temporary full stop, select if age is greater than 30, and then we'll run two frequency tables on the field job cat. And what we get is the first frequency table has a total of 336 cases because it was only those aged over 30. But the second frequency table has 475 cases because that selection was effectively temporary. So temporary is a really powerful command. We can use it with select if, but we can use it with lots of other procedures as well.